Hello, in this video, we're going to discuss comparing numbers that are written in scientific notation. Some things that we have to remember with scientific notation is that scientific notation is a very compact way of writing very large or very small numbers using powers of 10. So remember, if it's a very small number, that's where we're going to have a negative exponent with that power of 10. And then if it's a very large number, we're going to have a positive exponent with that power of 10. So a number that's written in scientific notation is going to have this form where we have a, and then this is our power of 10 with the exponent, which is going to tell us how many places are we going to move the decimal. We have to remember too that in scientific notation, this a, or this variable, whatever number this is, it has to be at least 1 and not greater than 10. So at least between 1 and 9. Okay, 1 and 9 is what that first number has to be. And then after the decimal, then you can have some more numbers. So it doesn't mean that there can only be one number. It just means that that number outside the decimal has to be between 1 and 9, and then you can have your decimal here, and then other numbers, and then your power of 10. Okay. Now, with this exercise, you're going to be dealing with inequality symbols as well. So inequality symbols are going to be used to represent which number might be greater than, or which number might be less than, or maybe it's equal to. And so in this case, when we have this less than sign, it's going to look like this, okay? Where you have some number, let's say we have the number 1, and then we have on the other side, we have the number 4. So we would read this from left to right where it says 1 is less than 4. And so we have to remember the inequality sign, the opening is going to point to the bigger number. Less than or equal to is going to look very much the same, but in this case, you could have 1 is less than or equal to 1. So in this case, it's slightly different than just our less than sign. Our greater than sign is going to be flipped the other way, where, for instance, we have, let's say, 5, and then on the other side, we have a 2. So we could read this as 5 is greater than 2. The opening of our inequality symbol is going to point to that larger number. And then greater than or equal to is going to be the same, but it's going to have this line underneath that's going to tell us we could have 5 is greater than or equal to 5. It could be the same number because it says or equal to. And then, of course, our equal to symbol is going to look like this, which just means that the two numbers are equal to one another, they're equivalent. All right, let's take a look at an example of this. So our first question is going to say which sign makes the statement true? And we have this number 5.13 times 10 to the negative 8th power. And then we have 5.13 times 10 to the positive 8th power. We have to compare these using the signs that are given below, which this first sign we have is our greater than symbol. So this would say that the first number is greater than the second number. The second sign we have is our less than symbol, which would mean that the first number is less than the second number. Or we have an equal to sign if they're equivalent to one another. When you're comparing numbers that are written in scientific notation, there's two ways that we want to do it. When I say two ways, there's two steps that we need to complete first by observing the question, by just looking at the question. So the first one is we want to compare the powers of 10, okay? So compare, especially if they're written in the same form, okay? I should start with that. So in this case, when we look at this question, they are both written in scientific notation. Okay. So they are both written in scientific notation, which that's going to tell us that what we need to start with is just comparing those powers of 10. Okay. So first we're going to compare powers of 10. We want to look in this case and see which one has the greater exponent that's attached, okay? And so when we have this number, we have 5.13 times 10, and then we have this exponent of a negative 8. And then on the other side, we have 5.13 times 10, and now we have a positive 8. So just looking at these exponents that are attached. We have a -8, a +8. We know that a positive number or a positive sign associated with the number is going to tell us that that number is greater, okay? Which means that this -8 is smaller than the +8. And so in order to select the sign that's going to make this a true statement, we want our sign to open towards the larger number or open this way. And so we have to point it this way, and this would be our less than sign here. All right, next question that we're going to look at is going to be very similar to the one that we just saw. So the first thing we want to do is just kind of observe, look at the question and see, are they both written in scientific notation? And we could say, yes, these numbers are both written in scientific notation. Okay, and so since they're both written in scientific notation, that's where we're going to look at those powers of 10. We're going to compare the powers of 10. So 9.53 times 10 to the 0 power. And then we have 9.53 times 10. And now we have a -1. Okay, so when we look at these powers of 10, we have a 0 and we have a -1. Even though 0 is neither positive nor negative, it is still greater if we thought about a number line. Okay, number lines here. And then we have 0 and -1. We have to remember that the further right we go, the greater the numbers get. Okay, so in this case, 0 is further to the right than -1 on a number line. So 0 is actually going to be larger than -1. So we would say that our opening of our inequality sign needs to point in this direction because this is the greater number. So it would look like this, or our greater than symbol. And we would read this as 9.53 times 10 to the 0 power is greater than 9.53 times 10 to the -1st power. All right, let's look at another example here. So when we look at this example that we have 974, and then we have 9.74 times 10 to the 1st. The first thing that we notice is that these are both not written in scientific notation. They're not in the same form, okay? And because they're not in the same form, we need to convert one of them to match the same form. Now, it really doesn't matter which one you convert. If you want to take the number that's in standard form, 974, convert it to scientific notation, that would be okay. And if you want to do it the other way, where you take the number in scientific notation and convert it to standard form, that would be okay. But what the main goal is to get both of those numbers in the same form, whether it's standard form or scientific notation. So in this case, I'm actually going to express the second number in standard form. So I'm going to look specifically at this number here. This number is written in scientific notation. And so I'm going to change this because I want it to be in standard form now. I want it to match the same form as that first number. So I want to put it in standard form. And in order to do that, we have to look at the exponent. So I'm going to say 9.74. And then this exponent here is going to tell me how many places am I going to move the decimal. Okay, and this is a positive one, which means I'm going to take this decimal and I'm going to move it to the right. Remember, a positive exponent is going to make that number larger. Okay, and so if you're completing a question and you have a positive exponent and your number becomes smaller, just take a look back at that and maybe see, did I move the decimal in the right direction? So in this case, we've got 97.4. Now it's much easier to compare these numbers. We've got 974, and then we have 97.4, And so we can see here that 974 is definitely going to be a larger number than 97.4. And so we have a greater than symbol. We want our opening to point to the number that is largest. And notice too that in the examples, the first couple of examples that we did compared to this example, it's very much similar, but at the same time, there's different steps that we're going to have to follow. There's different things that we need to observe when we're looking at the question to determine how are we going to answer this question. Okay, in the first couple questions, we saw that it was in scientific notation. We just compared those powers of 10. In this case, they're not both in scientific notation. They're not in the same form. And so that's where we'd have to convert at least one of them to that same form to match. All right, let's look at another example here. So we've got this question, 2.526 times 10 to the negative 10th power. And then we have 2.526 times 10 to the negative 9th power. So when we're looking at this, we can see that they're both written in scientific notation. So this is going to be similar to those first couple examples that we answered, where we're going to first just compare those powers of 10. So we've got 2.526 times 10, and then we have a negative 10 exponent, and then we have 2.526 times 10 to the negative 9. Now, it's really important too that we compare those powers of 10, because if we were comparing those coefficients, 2.526 and 2.526, we might think that these are equal, but those exponents are going to tell us a lot about our answer. And so when we look at these exponents, negative 10 and negative 9, we have to remember that number line. Okay, when you have the number line, and we know 0 is here, we'll say negative 10 is here, negative 9 is here, and then we have positive 10 over here and positive 9. Remember, the further to the right we go, the greater the number is going to get. So in this case, even though we're looking at a negative 10 and a negative 9, if you look at the absolute values of those, 10 is greater than 9, but we're not looking at the absolute values. We're looking at those as negative integers. So negative 10 is going to be less than a negative 9. So that means we want the inequality sign to point to 2.526 times 10 to the negative 9th power, because that is the greater number. All right, a couple more examples we have. So the next example that we're looking at is we have 1.85 times 10 to the 12th power. And then we have this very large number, 1,800,000,000,000. We want to compare these two and see which one is the greater number. So the first thing we need to notice is that they're not in the same form. They're not in the same format at all. And so we need to convert one of them to be in the same form as the other. So we're actually going to look at the first number, and we're going to convert this to standard form. Okay, so we have 1.85 times 10 to the 12th power. Okay, so since it's raised to the 12th power, that's going to tell us we're going to move that decimal 12 places. Okay, and so when we write this, I'm going to write this here, 1.85, and I am going to add a bunch of zeros because I know this is going to be a very big number. Just going to add a whole bunch. I haven't really counted them, but if we don't need them, we don't have to use them. Okay. And then what we're going to do is we're going to take this decimal, and this is telling us how many places are we going to move it. Since it's positive, we're going to go move this decimal to the right, making it a very large number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. And notice I did add too many zeros, so I can just get rid of these. I don't need them. And now when I rewrite this, I can say I have 1, 0.85, and then I have 1, 2, 3, 4, 5, 6, 7, 10 zeros. 5, 6, 7, 8, 9, 10. And I can add my commas, of course, here, every third number. Okay. And now these numbers look very, very similar when we convert it to standard form. However, we have to take note that this is 1, 8, and then a 0. And then this one, because if we look to, we have groups of 1, 2, 3, 4. So 1, 2, 3, 4 kind of matches, but this number that we have converted to standard form is 185, which is going to be the greater number. So we want this symbol, we want it to say 1.85 times 10 to the 12th power is greater than. All right. And then one more example that we have here. We have 5.9 times 10 to the negative 4th. And then we have 0.000059. We need to see which one is greater. And so again, we need to convert, looking at this, they're not both in the same form. So we need to convert to be in the same form. So we're going to take one of those numbers and we're going to convert it so that it matches. So again, I'm going to convert this one to standard form. So 5.9 times 10 to the negative 4th power. So that negative 4th power is going to tell us that we're going to move, how many places are we going to move the decimal? So I'm going to say 5.9. Now it's important to notice that this is a negative exponent. And so before we added our zeros on this side, but since this is negative, we're actually going to be moving the decimal in the other direction. And so I'm going to add the decimals over here instead. Okay. And then I'm going to take this decimal and I'm going to move it 1, 2, 3, 4 places. Again, I added too many decimals, but that's okay. I can get rid of these and I can get rid of these as well. And then I would have 0.1, 2, 3, and 5, 9. Now, when I look at these two numbers, 1, 2, 3, it's important to note how many zeros there are. I've got 1, 2, 3 zeros here, and then I have 1, 2, 3, 4 zeros here. Now, I know there's more zeros to the number on the right, but remember that the smaller the decimal is, or the greater the fraction is, the smaller the portion is, okay? And so in this case, this 0.00059 is actually a larger decimal than 0.000059, okay? It's going to be less, it's going to be a greater portion when we look at the fraction that we're working with. So we would say 5.9 times 10 to the negative 4th is greater than 0.000059.